Hey guys, today we are going to talk about graphing linear inequalities with two variables. So graphing a linear inequality in two variables has an ordered pair, x, y, that produces a true statement when the values of the x and the y are substituted into the inequality. So what that means is, here in example 1, it says which ordered pair is not a solution of x minus 3y is less than or equal to 6. All you have to do is substitute each x and y coordinate into the inequality to determine if it makes a true statement. So substituting below, if we took a and we have 0, 0, so we're looking at 0, 0, and we plug it in to x minus 3y is less than or equal to 6. Wherever I see the x, I'm going to put a 0, and then where I see the y, I'm going to put a 0. Is that less than or equal to 6? So 0 minus 0 is 0. Is 0 less than or equal to 6? Yes, that is. So it is a true statement. Okay, so it is. So that one is a solution. We're looking for the one that is not. So B, let's substitute in. Here's B. We're going to substitute in 6, negative 1. Again, we're substituting into x minus 3y less than or equal to 6. So our x is 6 minus 3 times our y is negative 1. Is that less than or equal to 6? This would be 6 plus 3 less than or equal to 6. 9 is less than or equal to 6. So we know that 9 is not less than or equal to 6, so that one would be a no. All right, if we did C, we would look at the point 10, 3 and substitute it in. So it's x, again, x minus 3y less than or equal to 6. So we would have 10 minus 3 times our y, which is 3, less than or equal to 6. 10 minus 9 is not less than or equal to 6. That would be a 1, less than or equal to 6. That one would be a yes. And then finally the D, we've got negative 1, 2. So let's check that one. Again, we're checking it against x minus 3y less than or equal to 6. We plug in our x, we get negative 1 minus 3 times 2 is less than or equal to 6. So we get negative 1 minus 6. And that would be negative 7. Is negative 7 less than or equal to 6? Yes. So the answer would be B, okay, because the only one that is no, and it's saying which ordered pair is not a solution. Okay, so looking now, it says tell whether the ordered pair is a solution. So I want you guys to pause the video right here and then come back and check it against the video. So pause here, I'm going to start. So if I did, we're checking to see if it's a solution of negative x plus 2y is less than 8. Okay, this would be a negative 0 plus 2 times 0 is less than 8. So this would be 0 is less than 8, and this would be a yes, because 0 is less than 8. All right, we take the point 0.04 and we plug it in. We're going to get a negative 0 plus 2 times our 4. Okay, is that less than 8? We end up with 8 is less than 8. So 8 is equal to 8, but it's not less than, so that would be a no. Okay, and then finally we're going to plug in positive 3, 5. So we would end up with a negative 3 plus 2 times 5 is less than 8. This would be negative 3 plus 10 is less than 8, or 7 is less than 8. And that's a true statement, so that would be a yes. Okay, so hopefully you get all those right in example 2. All right, now we're going to talk about graphing a linear inequality with two variables. Okay, so before you graph, it's really important. So when we had a number line and we graphed, if you remembered, okay, say we had something like this where we had x is less than 3, and here was our 0, this was 1, 2, and 3. What we would do is we would make an open circle, and then we would go to the left. Remember doing that? Okay, but if it was x is less than or equal to 3, we would then color in that circle. Okay, so with our lines, we're going to have something kind of similar, but what we're going to do is two things you need to remember. Before you graph, if an inequality is just less than or greater than, okay, so less than or greater than right there, okay, the line of the graph is dashed, okay? If the line of the graph is less than equal to or greater than or equal to, then the graph is actually solid. Okay, what I mean by that is, okay, say I had a line like this. Say it was well, let me do a better example here. Let's do the whole thing. All right, so say I had a coordinate grid like that, and we wanted to graph the line x is less than, no, sorry. Examples on the fly here. Y is going to be less than x plus 2. Okay, something like that. All right, so I'm going to start by graphing the y-intercept, which is 1, and then your x is going to be a slope of 1, so up 1 over. So say it looks kind of like this. All right, what I mean by, and let's just do, and then because it's y is less than, it's actually just going to be a dashed line. That's what I mean by dashed. Okay, but if it was less than or equal to, the line itself would be solid like that. That's what I mean by the difference. Okay, hopefully you understand that. Okay, so the first step, we graph the linear inequality. We make the line solid or dotted or dashed, means the same thing. Okay, and we use a test point. So I use 0, 0 to determine which region to shade, and then we shade the graph. So with the example we're going to use, okay, we're using the example y is greater than 4x minus 3. Okay, so we start out and we graph the linear inequality. I should have started with this one. So my y-intercept is negative 3, 1, 2, 3. Okay, my slope here is 4 because remember we're in the form of y is greater than mx plus b. So it's still slope-intercept form. So we started at the y-intercept. Now our slope is 4, so we're going to rise 4. 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. Okay, so it says make the line solid or dashed accordingly. Well, if you notice, it's just right here, it's just greater than. So this is going to actually be a dashed line, okay? So it's going to look like this. Okay, so there's your line. Instead of it being solid, it's actually dashed, okay? And then it says use a test point, okay? Because what's going to happen is you're not just going to have a line, but your solution is actually going to be a whole region, okay? It can be infinite numbers of ordered pairs, but it's going to be either on the right side of the line or the left side of the line, okay? So in this case, I'm going to use the point 0, 0, okay? So the 0, 0 is right here, all right? We usually use a test point, all right? Usually I use 0, 0, but if 0, 0 is on the line, you're going to have to pick a totally different point, okay? So when I use that test point, I just plug in, okay, 0, 0. So I'm testing 0, 0. All right. So in this case, 0 is going to be greater than 4 times 0 minus 3. 0 is greater than negative 3. That's a true statement, okay? Now, because that's a true statement, that means that the region, see the left side, this is what's going to be shaded. Okay, so I'm going to shade everything on the side. Okay, that's the true area. Okay, now had that been false, the 0, 0 had been false, then I'm going to shade it the other side. Okay, so we'll try a few more of these so you can see it. Okay, so again, you look for 0, 0, you test it. If it's true, you shade that side. If it's false, you shade the other side. And if you pick a point on the other side, any point, you could pick some, you could, if I pick the point, let's try it. I'm going to pick the point 1, 2, 3, 4, 4, 2. Okay, so 4, 2 is on the other side. So that's telling me that's not part of the solution set. So let's even check that and see. Okay, so if I plug it in, my y is 2, greater than 4 times 4 minus 3. Okay, I'm just checking it against that inequality, and this comes up as 2 is greater than 8 minus 3, or 2 is greater than 5, and that's false. Okay, so if you notice, it's in the false region. Okay, and that would be true for any of the infinite points that are on that right side. So this is the graph of the inequality y is greater than 4x minus 3. Okay? All right, so example number 4 says to graph the inequality x plus 2y is less than or equal to 0. So the first thing you have to always do is get it into slope-intercept form. So I'm going to rearrange the problem, and I've got a negative x, okay, plus 0, which I'm not going to write plus 0, but I am going to divide by 2. And this is important because you've got to remember that when you multiply or divide an inequality by a negative, you've got to remember to flip the sign. Okay, that's really important. We don't have it in this example, But right now, we're just dividing both numbers by a positive number, so it's not going to be impacted. All right, y is going to be less than or equal to negative 1/2 x. Okay, so there's our linear inequality. Okay, now we want to graph it. So we start out and we've got our slope is going to be negative 1/2 and our y-intercept is going to be 0. So we're going to start at 0 and our slope is negative 1/2. We go down 1/2, down 1/2, or we could go up 1 to the left 2, up 1 to the left 2. All right, now I take a look back and I see it's less than or equal to. So that means I'm making a straight line. It's not going to be dashed. It's going to be a straight line, just like that. Okay? All right. Use the test point. Well, we don't want to use the test point 0, 0 because it's on the line, so that won't tell us which way we shade. So let's pick another point, okay? Maybe 1, 0. Okay, we can use 1, 0. Or let's use something totally different. 2, 2. It's obviously on a side. Okay, the other one was a little too close. So let's check 2, 2. Okay, I'm going to plug it in, and it says, all right, we've got the equation y is less than or equal to negative 1/2 x. So 2 is my y, less than or equal to negative 1/2 times 2. Okay, so when I multiply that out, 2 is going to be less than or equal to 1/2 times 2 is negative 1/2 times 2 is negative 1. So 2 is not less than. It's actually a false statement. So that means this side of the line where the point is not going to be shaded, but we are going to shade this other side, okay, because the point we tested was in the no region. So now we actually are going to check the other side. So every point in that shaded region is actually a solution to the inequality. Okay, it could be any combination. We have an infinite number of solutions. All right, so let's go on and try to graph some of these. So now we've got a special case. All right, so back to our Hoy box. Okay, this is y is greater than or equal to negative 3. So I immediately have to the Hoy. So I've got a horizontal line, okay, at negative 3, 1, 2, 3. Okay, I look at it, and it's greater than or equal to, so I know it's a solid line. Okay. And it's greater than or equal to negative 3. So since it's greater than, actually, I find it's easier. You can pick the point 0, 0, or you can actually think of your number line, okay? And since y, and if you think of it as sideways, greater than negative 3 would be above the line like that. So you can shade it just like that if you can kind of see that it is above the line. It's greater than or equal to. So it would be all of these values here. Or it would work the same way if you decided to just test the point 0, 0, okay? So 0, 0 is right here. If we plug it in, our y is 0. We don't have an x. 0 is greater than negative 3. That is true. So it's on the true side, okay? All right, so now number 2, we've got x is less than or equal to negative 1. So we're going to think of box, okay? So we've got a vertical line at negative 1. Again, it's less than or equal to, so we've got a solid line. Good line. Okay, and treat and think the number line. This is your x. Anything less than, so here's your x, negative 1. The values of x less than would be to the left side, okay, of the number line, so it would look like this, okay? Or, again, we can check our 0, 0 point, okay? So when we check our 0, 0 point, if we plugged in 0, 0, we would say 0 is less than or equal to negative 1. Well, that's a false statement. So we know that the point 0, 0 would be on the false side. Okay. All right, so let's look at the next 2 examples. All right, these are probably good examples for you guys to try. Pause the video and then come back, okay? I'm going to go ahead. My slope here is 1. My y-intercept is 3. So when I graph it, start with my y-intercept. My slope is 1. And I notice it's just greater than, so I know I'm going to have a dashed line. So I'm going to make my dashed line like that. So there's my line. I'm going to test the point 0, 0 because it's not close to the line, so it's not on it. If I put in 0, 0, I've got 0 is greater than 0 plus 3. 0 is greater than 3. Well, that's going to be a false statement. So that means I'm not going to shade the side with 0, 0, but I am going to shade the other side. So it's going to look like that. Okay? All right, number 4, when I solve for my y, I divide by -4. Now, this is where I need to be careful. Notice I divided both sides by a negative, so now I'm going to flip my sign, and I've got y is greater than or equal to -4x. So my y-intercept is going to be 0. My slope is -4. I start at 0. My slope is -4. 1, 2, 3, 4, and over 1. Or I can go up 4. 1, 2, 3, 4, and over 1 like that. Okay, it's less than or equal to. So, I'm sorry, it's greater than or equal to. Greater than because we flipped it. So, but I was looking for that equal. So we are making a solid line. It's going to go like this. Okay, it's solid because it's greater than or equal to. And now we're going to test the point. We don't want to test the point 0, 0 because it's right on the line. Okay, but we can test the point 1, 0, which is right here if we want. Okay, or you could do 2, 2, or you could do anything. Okay, so if we test, okay, 1, 0, we go back to make sure, going back to this, is y greater than or equal to -4x? Okay, so this is going to be 0 is greater than or equal to -4 times our x, which is 1. So 0 is greater than or equal to -4, which that is a true statement. Okay, so that means we are going to shade that side. Okay, so we go here and we shade this side right here. Okay, all right, so now 5 through 10, all we're doing is telling whether the ordered pair is a solution of the inequality. So you're going to go in and you're going to plug these all in. Okay, your x here is 1. Your y is -10, so 3 times -10 is greater than or equal to -9. So 1 minus 30 greater than or equal to -9. 29 is greater than or equal to -9. That's actually a false statement. So this one is not. Okay, we're telling whether the ordered pair is a solution. That's a no. Okay, so you should be able to go through 5 through 10 and then go back to the key that's out here on student view, or actually, we'll put the key out on student view, but I mean on the class website, just so that you can compare them. So why don't you actually pause the video here and try up to number 10 and then check it. Okay. Now we want to practice graphing the inequalities. I'll do the first one for you, and then we're going to have you check them. Okay, so the first one, we're going to graph this. So our slope here is going to be 4. Our y-intercept is also 4. So 1, 2, 3, 4. Okay, slope is 4. 1, 2, 3, 1, 2, 3, 4, and over 1. Okay, 1, 2, 3, 4 over 1. Now this is less than, so it's going to be a dashed line. So let's do this 1, 2, 3, 4. Let's go over right here. All right, so we've got a dashed line. Okay, and we're going to check the point 0, 0. Okay, so when we do that, we plug it in. 0 is less than 4 times 0 plus 4. So, oops, it's supposed to be plus 4, not 0. Oops. Erase that. And try that again. Okay, so y is less than 4 times x plus 4 plus 4. So when we plug in 0, 0, we've got 0 is less than 4 times 0 plus 4. So 0 is going to be less than 0 plus 4, which is 4. And that's going to be a true situation. So the point 0, 0 is going to be on the side that we shade. It's going to look like this. Okay. Number 12, if you want to pause it, you can and try it yourself. Okay, so if I start at the y-intercept of 1 and my slope is -1, so my b is 1, my m is -1, I'm going to go down 1 and over. It's going to look like this, okay, but it is greater than or equal to, so it's going to be a solid line like that. Okay, all the way up. And we're going to check the point 0, 0, which is right underneath the line. So if we check 0, 0, we'll get 0 is greater than or equal to. -0 is just 0 plus 1. 0 is less than or equal to 1. That's false. So that means we're not going to shade the side that has the 0, 0, but we're going to shade the other side. Okay, and you can always test any point and make sure that it works. Okay, so you guys go ahead and try 13 and 14. In both cases, you've got to remember to solve for y, put it in slope-intercept form. Y equals mx plus c. So get it into that form, and then try it yourself. Okay. Again, go back to the key that's on the class website and compare it. Make sure you got the right answer. All right, then we're going to jump ahead to the word problem here. Okay, it says you need to bring a duffel and a bedroll for a trip to the mountains. The sum of their weight, x, in pounds of the duffel and the weight, y, in pounds of the bedroll, cannot exceed 30 pounds. Write a linear inequality that describes the possible weights of the duffel bag and the bedroll. So our last statement is, in this case, they gave you the x is going to be the duffel, and your y is going to be the weight of the bedroll. Okay, and you can see the graph here. The duffel is your x, your weight is the y. Okay, so you have your duffel as being your independent variable, and your weight and your bedroll being the dependent value. All right, we're going to write a linear inequality that describes the possible weights of the duffel bag and the bedroll. Okay, so it says that you cannot exceed 30 pounds. So if you take your duffel bag and then you add your bedroll, okay, it's got to be less than or equal to 30. Okay, so we solve for y, bring your x to the other side, and we get a negative x plus 30. Okay, so there's the equation of the inequality. Our y-intercept is at 30, so we start right here. It looks weird, it's just the first quadrant. Okay, and our slope is going to be negative 1. Okay, so notice, be careful. Luckily, we've got, this goes from 0 to 5, and both scales are by 5. So a 1, we would just go down 1 and over 5, 5 and 5, okay, and it would look like this. Okay, it is a solid, it is less than or equal to, so we're going to make a solid line like this. Okay, this is really the only piece, the quadrant 1 would be the only one we're working with because obviously weights are both positive. Okay, and then we test the point 0, 0. So if we put in 0, 0, okay, we would get 0 is less than or equal to 0 plus 30. Is 0 less than or equal to 30? That would be true. So that means we would want to shade this side right here. Okay, so any combination of duffel bags and weights in this region would satisfy the inequality. Okay, so again, go back, check out the answer keys, hopefully, and if you need any additional help, then you, on the homework, I'll try to provide a homework help video as well. So you should have any kind of video having done. Bye.